This is the symbol for a NPN transistor. And how they're built, I'm going to use silicon media here. They start with an area that is doped N, and then they continue as they grow this thing, dope the next section P, and if they were to stop there, we'd have a diode like this. But they continue on and dope the next section N, and it actually looks like this. If you measure it with a meter, you've got two diodes back to back. And here's the label for this chunk of silicon. Now, it has to be grown in one continuous media. Wiring two diodes back to back won't make a transistor. A transistor can be used as a switch, on and off, or it can be used as a variable resistor. And that would be between the resistance between E and C. And how you vary the resistance or turn it on and off is applying a positive voltage to the base. I have this circuit on the breadboard. We've got an NPN transistor, and we're going to be taking a look at C, the collector, and also B, the base, and see what the relationship is when we vary the voltage on the base. We'll see how the voltage changes on C, the collector. The emitter is grounded here, and I've got an LED so you can easily see when the transistor is conducting. Here's the video. Okay, I've got the meter hooked up to the base right now, and as you can see, the LED is off. I'm using that as an indicator so you can see when the transistor is conducting. And if I turn this up, we can see with that we've got 0.7 volts on the base and the LED is on. So you can bias this LED like a switch, off, on. Okay, let me turn it off here. So let's take a look. That means that the transistor has got its highest resistance, or practically infinite resistance. Oh. Now that looks good. Okay, so we got 10.2 volts. Let's see when this thing starts conducting. Okay, 0.1 volt. .3. Okay, now this is germanium transistor. It would have started conducting, so we have a silicon transistor here. So let's up this a little bit more. Oh, it's just started conducting. Let me back that off a little bit. Oops, too far. Okay. About right there starts to conduct. About 5.9. Kind of hard to see right there. Okay. Okay, now this is on all the way. Okay, but you see that we could vary it. And let's see what we've got here. Oops. Okay. Max was 10.2 when the transistor was totally off. If we bring this up to, oops, wrong way, a little over 5, that would be just about the midway point, since the total was 10.2, and we've got a little over 5 volts there, so this would be considered Class A biasing. Now I've driven it into saturation. In other words, now this transistor is as low ohms as it can be. Now it is at high ohms as it can be. Get back to about 5. That's about in the middle. Let's see what the bias is. It's pretty critical in this circuit. 0.64. And if I go down just a little bit, it's off. Now it's in saturation. Transistors are very interesting devices, and they're inexpensive. I hope you do some experimenting. Thanks for watching.